morning and welcome back to another episode of 56-Bit Cloud Cafe. I'm Atir Dalal and today we have an exciting episode lined up as we delve into the interesting technicalities of RDS. Hello everyone, welcome back. This is our last episode in the RDS series. Hello Patrick.
Hello Atir.
So let's start. What advanced features does RDS offer?
Right, so as with everything in AWS, there is the easy way of creating things and then there is the harder way of creating things. With RDS it's the same thing. There is the easy options, which you just use to create your first database, and if you don't need advanced features, you just don't use them. But once you start going in deeper, especially with scale, as you get a lot of requests to your website, to your application, you will need to start thinking of what features to use to improve the scale of RDS. Not just the scale, but it could be reliability, it could be security. So the deeper you get, then the more you will be confronted by these problems which you need to solve through these advanced features. Some interesting features that RDS has, which are considered a bit more advanced, you definitely do not need to use these are optional, but they can get you out of some problems with scalability, security, reliability, etc. The first one I would mention is multi-AZ. It's one of those things which you would go on to by default. So multi-AZ means basically when you create an RDS instance or RDS server, you will get a single server. Now that server is inside a single availability zone, a single physical data center. To increase your reliability, we shouldn't put anything in a single availability zone. We should always put them in at least 2 availability zones. So multi-AZ allows you to have a server in one AZ and then another server, a replica of it in a different AZ. This increases reliability big time, but it does not increase scalability. It doesn't increase your ability to be more performant when there is a larger amount of requests. So these 2 servers will sync with each other, but you can only read and write from a single server. You cannot use the other one for reads and writes. The other one is just there, sitting there, in case something happens to the first server. And if something happens to the first server or the whole availability zone, then yes, it will automatically start the other server and work with it. It will be already started, but it will change towards it and you can start using that one. So multi-AZ handles our problem of reliability. What about scalability though? So the first thing you need to think about is whether it is your application has more reads than writes. If there is more reads, your application does a lot of reads to the database, there are a number of options, advanced features that you can use. If you're using MySQL or MariaDB, you can use what are called optimized reads. This is a feature which allows faster reads on specific type of servers. A bit more advanced feature would be to have read replicas. So you add more servers in different AZs if need be, or in the same AZ, and you can do reads across all these servers. So here you are increasing scalability. You can even have replicas across regions to improve reads for customers who are not close to your main region. They are closer to other regions. There is also the option of using provisioned IOPS. So by default, your database will store its data on normal hard disks, what we call EBS, over the network. And these hard disks have a specific set amount of a limit to how much they can be performant, how much they can perform. By using provisioned IOPS disks, you are increasing that limit and you're making that performance more reliable. It stays performant for a longer period of time. So provisioned IOPS, read optimized reads, read replicas, all these can help you scale when it comes to reads. When it comes to applications that have a lot of writes, then it's a bit harder because of the way SQL works. And probably one thing you can do is, again, go for provisioned IOPS. This will help you with writes as well. If you're using MySQL or MariaDB, you can go for optimized writes. And another thing you can do is RDS proxy. RDS proxy allows you to have a middleman between your application and the server and the RDS instances, and it controls the connections that your servers create with the database. So it makes sure that whenever there is a connection, that connection is not left there taking up resources forever without requiring it. So it will handle the life cycle of that connection. It will ensure that connections, if you have 50 connections and you need 60 of them, it will kind of buffer it in a way which will ultimately improve scalability and reliability as well. So RDS proxy and provisioned IOPS, as well as increasing the size of your servers, all that can help you a lot with writes. One final feature I want to mention, which you can consider as advanced, would be blue-green deployments. Blue-green deployments do not help you with scalability at all, they help you with reliability. So whenever you want to do a change in your database, whether you want to move to a higher version or you want to introduce some changes in the way the data is stored inside those databases, you can use blue-green. Blue-green basically means that AWS automatically will bring up a new server, or more than one, and will move to the new system whilst the old system is still there. So the old is known as blue, the new is known as green. And the failover from one to the other is quite seamless. RDS helps you to do this very much out of the box and managed by AWS. So all these features are interesting if you reach certain limits of scalability, reliability that you might want to use to get out of those problems.
Okay, that's great. What considerations should organizations keep in mind when migrating their existing database to RDS?
Okay, interesting question. Migrations. Ultimately, if you are not on RDS and you want to move to RDS, there is going to be a migration of data. Data is rarely just sitting around and we can just put it on RDS and no system will use it until we decide to start using it. It doesn't work like that. Most of the time, your data is being actively used on the old system, let's say on-premise, and you want to migrate it to RDS, and you don't want to have any downtime, or very little downtime is acceptable. So migrations are an essential part to the process to make sure that you don't go down during that process. There are other considerations, right? So downtime is one of them, but you might also want to consider security of the data being moved from the old system to the new system. How will you do data backups in the new system? So at the moment you might have a database on premise which is being backed up properly. So let's make sure that the same or even better data protection is in the cloud as well. How will you do monitoring, analytics once we migrate? How will our applications respond to this migration? How will they connect to this new database? So all these considerations need to be taken when migrating from anywhere to RDS. I think it's best also to take everyone on a bit of a journey of how a typical database migration would look like, with examples, right? So let's say I have an on-premise MySQL database. It is on a server, or on multiple servers maybe, on-premise. and we're going to move it to RDS. The first thing we need to choose is the region. So where will our data physically reside? So in AWS, regions allow us to decide where our data will actually be, data residency. So let's say we choose Ireland so that we are inside the European Union for GDPR reasons. Now, once we decide on Ireland, we go in there, we go to the RDS console, and we create a new database. So the first thing we have to choose is the type of instance to actually create, to actually use. So you can start with generic instances, which have a good balance between memory and RAM, between memory and CPU. But you can also go for more expensive, but ultimately more memory optimized instances, which could make sense in your use case, depending again on the scale of the data, how much data there is and how much it will be requested by the applications. So once you decide on an instance, so we're choosing MySQL, I would highly suggest you also go for Aurora as a default when using MySQL or Postgres. Then you might want to choose the size of the database server. So not just the type of server, but also the size. Ideally, you have a big buffer because of the migration. So because data is going to be injected into a new system, we're going to have to put up a much bigger server than we need, and then we bring it down later to reduce costs. Then the question comes, once the RDS instance is created, you're going to have to think about backups. So when and for how long will we do backups? You're going to have to think about monitoring. So for example, in this case, we're going to switch on backups for automatic backups for 35 days. And then we're going to have another system, a Lambda function, for example, to do backups every month manually through the program. And it will keep those backups for, say, 12 months. What about analytics? How will our analytics system connect to this database? So here we can talk about DNS and connectivity to ultimately get to that database, and security as well. We switch on encryption. We make sure that our applications can connect to that database in an encrypted manner. Finally, we come to the actual migration. So migrating the data from on-premise to AWS, to RDS, and then switching off or removing all the connections from the old on-premise system. Now, to do this, there is a very good service in AWS. It's called Database Migration Service, or DMS, which allows you to do this in a very non-managed, very highly managed way. You don't have to do much. So you connect the source, which is the old database, you connect the new database on RDS, and you start replicating the data. Once it reaches a certain point, then it will switch off the old database, and your new database comes online. Then, of course, you have to think about costs. Once you have a settled amount you have settled down into your new environment, into your migrated environment, you can start thinking of reducing costs. So you reduce the size of your server if need be. You might want to use reserved instances, which allow you to buy 1 year or 3 years worth of servers in RDS at a significant discount. You might want to monitor your system to see if there is any extra usage that you can ultimately get cost reductions from. So the journey starts by a lot of planning, going into migration itself, and ultimately lots of testing first of all, and then the migration itself, and then ultimately iterating on those best practices to make sure that you are cost optimized, you're scalable, reliable, and the data is protected.
Thank you, Patrick. We have now reached the end of our episode, which is also the last episode of the RDS series. Next time, we will be discussing AWS identity and access management. Thank you for listening, and as always, happy cloud computing. To stay connected and never miss a beat, be sure to follow our podcast channel for the latest episodes. Also, you can follow us on Instagram, Facebook, Twitter, and LinkedIn to know more about all the updates in Cloudfield and to know more about our upcoming webinars and events.